Hi, I'm Robert, and this is a lathe. Lathes, like the one behind me, are used to machine circular parts or features. The major components of the lathe are the headstock, spindle, carriage, tool post, tailstock, and bed. The workpiece is installed in the spindle, which rotates when the machine is turned on. Tools are installed in the tool post, which is attached to the carriage. The carriage can be moved in the X direction and in the Z direction to make cuts on the workpiece. The compound rest moves the tool simultaneously in the X and Z directions at a set angle. In this video, we will demonstrate basic facing, turning, and drilling operations on the lathe by machining the features on the bottom of the punch knob. We will begin by machining the nub on the bottom of the knob, which has a diameter of 0.438 inches and a length of 0.375 inches. Install a piece of stock into the spindle. Some lathes will have a 3-jaw chuck installed on the spindle. Place the stock into the chuck, then use the key to tighten. The key should be removed immediately after use. If the key is left in the chuck and the lathe is turned on, the key can be thrown out of the machine and cause injury. Some lathes will use a collet changer instead of a 3-jaw chuck to secure the workpiece. Select a collet that matches the outside diameter of the stock. Install the collet and part into the spindle, then tighten the drawbar. The drawbar must be tightened such that pulling the lever on the drawbar locks the collet into place. The handle will pop when the collet is locked into place. If the drawbar is not tightened enough, the lever will fully extend but will not lock. If the drawbar is too tight, it will not be possible to fully extend the lever. When the drawbar is tightened properly, the handle will lock into place when fully extended. A turning tool will be used to cut the initial features on the knob. Turning tools can be used for both facing and turning. Facing is cutting a planar surface perpendicular to the axis of rotation. Turning is cutting a circular surface parallel to the axis of rotation. Install the tool and tool holder onto the tool post. The tool should be centered vertically on the part. Check the tool height by touching the tool lightly to the part with a small steel rule between the part and the tool. The rule will sit vertically if the tool is centered. If the tool is too high or too low, loosen the handle, adjust the height using the nut, retighten, and check the height again. Check that the tool angle is appropriate for both facing and turning operation. The tip of the tool should touch the part, leaving a relief angle between the tool and the part. Ensure there is good clearance between the part and the tool holder. If the tool angle needs to be changed, loosen the nut on the top of the tool post, rotate the tool post, tighten the nut, and recheck the tool angle. Turn on power to the lathe using the switch on the back. Pull the handle up to turn the spindle on, spinning forward. Always verify that the spindle is spinning in the correct direction. In an emergency, press the emergency stop on the front of the machine, or step on the pedal at the base of the machine. Either will stop the rotation of the spindle. Adjust the spindle speed to 1200 RPM. Make initial facing passes on the part, removing any rough surfaces from the bandsaw. Facing passes should be a maximum of 50 thousandths deep. Make a finish pass 10 thousandths deep. Before starting the cut, zero the Z-axis on the digital readout.
A 10,000th finish pass with smooth, consistent feed will produce a good surface finish. The bottom surface of the knob is now finished, with the Z-axis zeroed on that surface. Next, we will machine the outside diameter of the nub down to 0.438 inches for a length of 0.375 inches. Make 1 or 2 turning passes on the outside of the part until the original outside surface of the stock has been completely machined away. Zero the X-axis of the machine on the final pass. Cut to a Z distance of 365 thousandths. This will leave 10 thousandths at the end of the length for a finish pass. Zero a caliper at the desired diameter of 0.438 inches, then measure the turn surface to determine how much material must be removed from the diameter of the part. Begin making turning passes on the part, removing at most 100 thousandths from the diameter of the part at a time. The digital readout will read on diameter. If the digital readout reads 100 thousandths on the first pass, the depth of cut will be 50 thousandths, reducing the diameter of the part by 100 thousandths as indicated. Once the diameter has been turned to within 100 thousandths of the desired dimension, zero the X-axis, stop the machine, and measure the diameter again as before. Continue to make passes to a diameter of 0.448, leaving 10 thousandths of an inch for a finish cut. On the finished turning pass, cut at a diameter of 438 thousandths to the full length of 375 thousandths. Smoothly feed out on the X-axis to perform a finishing facing pass on the underside of the knob. Next, we will drill the hole in the bottom of the knob. The part print calls for a 1/4-20 threaded hole, 0.75 inches deep. Install a drill chuck into the tailstock of the machine. Friction on the tapers of the drill chuck and the tailstock will secure the chuck in place. If the lead screw on the tailstock is fully retracted, the drill chuck will hit the bottom of the taper on the tailstock, and it will not be possible to install the drill chuck. Similarly, the drill chuck can be removed by fully retracting the lead screw on the tailstock. Install a center drill into the drill chuck. Unlock the tailstock from the bed, slide it close to the part, and lock it in place. Center drill a small hole in the part. Replace the center drill with a number 7 drill bit. Lightly touch the drill bit to the part, then zero the dial on the handle. Turn the spindle on at 1200 RPM and peck drill to a depth of 0.75 inches. On the machine used in this demonstration, one rotation of the tailstock handle is 100 thousandths, so this requires 7 full 100 thousandths rotations, plus an additional 50 thousandths. It can be difficult to count rotations of the handle when peck drilling. The markings on the side of the tailstock spindle can be used to help keep track of roughly how deep the hole has been drilled. After drilling, clean up the lathe. Remove the part and tools. Blow chips off the machine and wipe down any oily surfaces. Pull the chip pan out of the machine and remove chips. Sweep up around the machine.